Hey, it's Miss Phelps, and once again, it's been a crazy weekend, and I'm just getting my video done. I'm so sorry. I hope you've had a great weekend. I know the weather has been absolutely wonderful, and I've really enjoyed it. But today I want to talk about dilations, so let's go ahead and get started. Now, over on the right, you can see I've actually made two different sets of dilations. So I want to start with the little triangle, the one in the middle. And the triangle in the middle is my pre-image or my original. And I actually did two different ones from that. And I started and I made a smaller one, so I multiplied times a scale factor that was 1/2 the size of my original. And then I made a bigger one, so I multiplied by a scale factor of 2 on that one. Okay? The one on the the one on the left, which is rectangles, I did the exact same thing with. So I started with my original, which is in the middle, and I first multiplied it times 1/2, so that made my little small one here. And then I took my original and I multiplied it times 2, and I got my bigger one down here. So let's go ahead and start with the notes. So first of all, definition. A dilation is a transformation that stretches or shrinks a figure to create a similar figure. So that means all of their angles are the same, but the lengths of their legs or sides are different. So let's go on. And here's the rule for dilations. And we've been talking a lot about rules this past week with rotations and reflections and translation. So here's the rule. If you start with if you start with X and Y, then it changes to you're multiplying K times X and K times Y. And K is my scale factor. So if it tells you that you're multiplying times 1/2, then my scale factor would be 1/2, okay? Alright, so I've got two examples for you, and please do not think that these are the ones that are on the screen, because they are not the ones on the screen, okay? So I've got point P, which is at 5,2, and it's dilated by a scale factor of 3. So that tells me that I'm going to multiply my X times 3 and my Y times 3. And here's what that looks like. So I've got 5 times 3, and then I've got 2 times 3. And that leaves me with 15 and 6 for my new X and Y numbers for my prime image. Alright, and then my next one, I'm going to multiply point A, which is 6 negative 3, by a scale factor of 1/3. If it's getting smaller, you multiply by a scale factor of a fraction. So this one's going to be multiplied times 1/3. And you can do this in your calculator, or these are easy enough that you should be able to do them in your head. Okay, so I've got 6 times 1/3, which is going to give me 2. And then I've got negative 3 times 1/3, which is going to give me negative 1. And there's my mistake right there. My parentheses sign is on backwards. Okay, the other thing, let me go back down here. Okay, the other thing that I really want you to notice is that all of these lines are going to tell you that they are similar figures. Because each of these lines, as they make the diagonal, they touch each of those points. So I've got one here, and even on my big triangle. And it's the same way on all three of them. There's my point, there's my other point, and there's my little point. Alright, and even on the last one, I've got one here, here, and here. So they have to actually start at not at the origin, but at a central point, and as you can see, they all start at the origin, and then they go out from there. And that's what proves that they are similar, is if they can go along that line. Now, I did the exact same thing on this other one, so as you see, it hits this point, and that point. Okay, and the same thing with the top line and the bottom line. Okay. So this pretty much tells you that they are definitely dilations. So I hope you've had a great weekend. I tried to make the lesson short for you. Have a great weekend, and don't forget to make good choices.